Hi, it's Richard Erickson. So I'm sorry about the previous one that I sent is one of them got mistaken. So here's my project about measuring reaction times from the class of Basic 100 by Wilman Clark. So the materials we need is a piece of hard time strip, a piece of paper to record the data, software of Microsoft Excel, and the equations below. It's 8 half GD square t square roots of 2h divided by g, and the acceleration of gravity is basically 10 meters squares per square. So the process we need is prepare direction time measure sheet, choose the subject for this experiment, someone hold direction time measure sheet particular for subject, drop it without any warming or contact counting. The subject should pay attention to either the holder swinger or direction time measure sheet. The subject hand will be placed at the 0 point of the sheet, then catch as soon as he can. So here's basically reaction time sheet with the distance of centimeter with 0.5 centimeter. We got the time of ms 31.62, and then with the distance of centimeter we will get a 44.72, and the rest is below this table. And then this is my graph. It's basically the distance follows by the unit of millimeter versus the reaction time of ms. So as we can see over here, as the distance increasing, the graph it's like becoming more steeper with the upward sloping. And as we know, the distance is using the formula half times acceleration time times t square. We know the acceleration is constant of 0.01. And then this scenario graph, it's basically distant volume of millimeter versus the reaction time. So after we calculate the reaction time, it's uh, square roots 2 times distance divided by acceleration. As we can see here in the graph, it's as the distance is increasing, the graph is becoming more flatter. We know the acceleration is constant of 0.01 and the falling distance. Here's my table of male reaction time and then female reaction time, 5 of each of them. In all of data that I got is the average of all subject is 159.51, and the standard deviation of all subject is 30.28501193. And we go over the questions. In your opinion, did the external stimuli use of acceleration times? Well, yes, the external stimulus is used to affect subject reaction time. If there's external stimulus applied, the person cannot concentrate. So basically, the reaction time is become slower. And in contrast, if a person concentrates without the external stimulus applied, the reaction time of this person will tend to be more quicker because he can fully pay attention and focus on it. And then question number 3, can you come to a conclusion about reaction time of male versus female where there are minimal external stimuli? Can you come to a conclusion about reaction time of female versus female when there are an external stimuli? Well, based on my data available, reaction time of female versus male without extraneous or with external stimuli, females tend to be more reaction than the males. And then question number 4, do your research have any bearing on the effect of taking cell phone when driving? Well, taking on a cell phone is considered as external stimuli since a person who's driving cannot fully pay attention on it. Therefore, the driving person will have slower reaction time. And then imagine that you are measuring the reaction time of someone with an external reaction time. Will the current car stop will be suitable? Why or why not? And how might you measure this person reaction time? Well, on the first one, no, if the t is longer than 2, the time the length of the sheet will no longer than 20 meters, so it's not suitable for the extremely low reaction person. Or we could use the longer sheet to measure, and with the help of the advanced technology such as millimeter watts to measure this person. And imagine that you were measuring reaction time of someone with an extremely fast reaction. Will the current stock will be suitable? Of course, like for instance, like t is 0.1 second, so the distance is only about 5 centimeter. So basically, the car stock will be suitable. And then we might use another device as such a millimeter timing watch. When a person catch it, we click the button. I think it's the most accurate thing that I got in my mind. And then discuss any difference between the Earth and the Moon regarding the concentration of our Earth's for each place. Well, the difference all about the gravities is that our gravity is 10 meters per second. On the Moon only has a 1/6 as much as the Earth does, so it will drop slower in the Moon than the Earth. If a person had a very long reaction time, would it be easier or harder to measure person reaction time on the Moon with the Moon Earth strip than for the same person on the Earth using the Earth as we discussed? Well, if the person has longer reaction time, it will be easier to calculate in the Moon with the current strip because in the Moon gravity is much lower than the Earth. If a person had a very short reaction time, will be easier or harder to measure a person's reaction time? Well, it will be also easier because to calculate the reaction time with the current strip, but we will use different units or lower than millimeters such as nano, I think. And then is it possible to use reaction time measurement from the Moon or the ship on your subject on Earth to obtain the correct reaction time for your subject discussed? Well, it cannot because the G is different, as we know that the Moon has very lower than the Earth does, with the formula of D half GT squared. Well, that's all for today. Thank you for listening, and I'm sorry about the other mistaken one. Thank you.